Alright, so this one's should be a relatively easy factoring problem. Of course, at the beginning it's not factoring yet. But you know that the last step in any fraction problem is, can you reduce it? And for us, we realize that means, can you factor the top or the bottom? And then is there anything common? So what can I do very first thing? They both already have the same denominator. This is true. So what's on the top here?
X squared.
Yeah, if I did 4x plus x squared minus 21, what's kind of wrong there? Average. Yeah, it's in the wrong order. I like it.
X squared first.
Yeah, put x squared first. Now at this point in the class, you can't say that the bottom is a hard factoring problem. You cannot. You're not allowed to say that. You're not allowed to think that. This top has got to be easy. Because what two numbers multiply with negative 21 add to be 4? 7 and negative 3. And see, the bottom would be a hint, but we don't really need it. But it's there. So you know it's going to be 7, and then it's got to be negative 3, and sure enough that makes 4. And then you get, yeah, these go away. So you get x minus 3. Bam. So the things you are canceling, they have to only be involved in a multiplication problem. You can't be adding to something else. Right? Because division doesn't cancel addition. I like it. Okay. So that's old stuff. If they already have the same denominator, you slap the tops together, put it in the right order, factor it, and see if it cancels. Right? The last step in a fraction is always, does it reduce? Right? So let's look at some old stuff to get into some new stuff. All right, let me see. Ooh, there's a lot of space here. I like it. So, help me out here. Alright, so I'm going to show you the way that I've shown you before. And I showed you that way because, number one, it makes this a lot easier, especially when the numbers get gross on the bottom. And number two, it makes, when there's variable expressions in there, it makes it possible, period. It's the only way you can do it. Bless you. What's the biggest number, obviously, that goes into 21 and 14? 7. 21 is 7 times 3. 14 is times 2. So remember, the way I looked at this is, and this, let this make sense. I'm trying to make them both the same. So if I can see what they're both missing relative to each other, and I give them both what that is, they're going to end up being the same. So what's the first dude missing that the second dude has? 2. So if I give him a 2, and to make it legal, I got to do it to the top and the bottom to make that legal. Keep the proportion the same. And what's this guy missing that he's got? 3. So I factored the bottom. I saw what they were each missing relative to the other one, and I gave them that thing. And now both of the bottoms are what? You do it. What are you on the bottom?
42.
42. That's the answer. Everything. So we have 8 over 42 plus 15 over 42 is 23 over 42, and that doesn't reduce, so I'm done. So what will it look like with variable expressions? Deep breath, that's a good idea. I need to make my own problem. Let's see. So let's see, what's the first step? Factor anything you can on the bottom. So you can see what they're made of. So you can see what the other piece is missing. So how do I factor this guy? And again, this is another problem that's going to have a hint in it. Yeah, it's going to be minus 9, positive 3. You would get that anyway if you didn't use the hint. So who's missing what?
The second one's missing x plus 3.
Yeah, the second dude is missing an x plus 3. I'm just putting him in those freaky brackets just because I want you to see that's what I'm adding. That's what I'm adding in, right? That's what I'm giving it. I like it. So now let me see. Now this is the way I try to show people, but I want you to be... You could do this one of two ways. You could distribute right now. You guys are not aware of the mistakes you can make. So let me do this. Let me do this both ways. Okay? One way I can do this, and the nice thing with this way is I'm not going to forget the negative, and I'll show you. Remember that stupid negative in the middle?
Yeah.
Always finds a way to mess this up. So if I just write x minus 2 times x plus 3 over x minus 9, x plus 3, that's cool, right? That's basically what x minus this.
Yeah.
Is that cool so far? The mistake people make is they then cancel the x plus 3's. Why is that a mistake? Why can't I not do this? Why can I not cancel those? What's the operation on the top? Minus. This x plus 3 is part of a subtraction problem. You can't break into that problem and take a part of it out.
Can you do that before?
Now wait. Stay with me. Now up here, could I reduce these?
Yeah.
Well, why is that kind of silly? Because I put it there so that what? So that the bottoms will be the same, right? You guys see that? So,
If you took it away on the
of course you could cancel these. Of course you could. But you're the one who put them there. We put them there. Why did we put them there? So the bottoms are the same, so I'm able to do this subtraction, right? I need LCD before I can combine fractions. I like it. Stay with me now. Let me show you a different way to do it then. If you feel like you're going to make that mistake, and that's a really easy mistake to make, then you have to be careful about not making the negative mistake. So that's one way to do it. The way to finish this out would be, now I can see negative 2x, negative 6. See, I don't make a negative mistake because it's more in my face. And then I get negative x minus 6 over this. Just putting my like terms together. Nothing cancels, so I'm done. So let's do that again, but let's do it a different way. So that's one way to do this. But it's really easy for your brain to just go, oh, sweet. Those go away. But that doesn't make any sense. I had to put them there so I could even do anything. How can they just immediately go away? That doesn't make any sense. So, what's the other way to do this? So let me rewrite where I am right now. I've got x over that's where I am right now. I just rewrote this here. You guys with me? Now, if there's a negative in the middle, the way you can do this to be careful about it, is write plus a negative. Plus a negative. Do you guys see that? You remember that? 7 minus 2 is 7 plus negative 2. Is another way to write it. Now, why is that a better way to write this? Because now you can see it is a negative 2 you are distributing. So the big mistake you can make here is to say this is minus 2x plus 6, because you just see a 2 there, right? You don't realize that the negative's got to go through the both. So now what do I get when I put them together? I get negative x minus 2x minus 6, which is the same thing I got over there. All over x minus 9, x plus 3. And then you just combine your like terms on the top. Negative x minus 6 over x times 9, x plus 3. Same answer we got before, just a slightly kind of different take. Depends on which mistake you think you're going to make more often. Are you going to make a mistake with the negatives? Then don't do this way. Are you going to make a mistake killing this dude? Then don't do this way. And if you're like, I'm going to make a mistake either way, then just pick a way and be really careful. Obviously, we just did one of them, so let's do another one. Let's see. Let's take some of what they made for us. Let's see. Here we go. Here, number 4. That's the nice one to start. You guys do this one. Try number 4 out. This is page 178. This one's interesting. Some of you guys might not have to factor it. You can just kind of see what one of them is missing. Or you factor the one you can.
Is it 15? What's 7 minus 15?
Alright guys, so which denominator can you factor? Can you do both? Yeah, this guy. This guy is just sitting there, he's all good, there's nothing that comes out of him. This first guy, what comes out? 3. So they both have an x plus 4 already. This guy's just missing 3. You guys see that? I mean, that's... Please let this step be easy. Now, obviously, as I said, if you don't know how to factor, chapter 7 is impossible for you. Period. So, if you're having a lot of trouble with factoring, you have got to focus on that now, immediately, urgent. Otherwise, you're going to fall way the hell behind in chapter 7. Chapter 7 builds on your factoring ability. Now, if you can factor, this is relatively simple if you let it be. There's a couple things that I just talked about, the kind of mistakes you can make when there's a minus in the middle. If you factor, you can see, this guy, they both have x plus 4. He's missing a 3, so you give him a 3. It's just so nice. You give them what they're missing. And then, of course, they end up being the same. So now, what do I get here? I get 7 minus 15 over 3 times x plus 4. Negative 8. Right. And that doesn't go anywhere. Nothing cancels. Now, how's that so far? Is that decent?
Yeah.
So you factor everything you can on the bottom so you can see what they're made of. And then you can see what parts the other one is missing. So before I do number 3 is interesting. Let's try number 5 out. 5 is not too bad. So which one can you factor, or can you do
Second
both?
one.
Just this one dude here? What can you do with this guy?
Take an X out.
Take an X out?
X minus 3.
I like that. And then this guy is obviously missing
X.
an X. He's already got an X minus 3, so he's just missing an X. So if you give him an X, both the bottoms are the same.
Is that easy?
Yes. I like that. Sounded like an affirmative sound. So then what do you got on the top? You get X minus 2 over X times.
X squared.
Notice how you basically just leave the bottom factor. Don't re-multiply the bottom, because then you won't be able to see if anything cancels. Just leave the bottom in parts. It'll give you a more interesting problem. This is fine. So on the next page, number 7. Belinda? Diana?
Well, this man could be both.
Kristen? Alright, so this is a classic problem. Both can be factored. So how do you factor the first dude?
2 and
X plus 3, X plus 2.
I like it. And this guy,
2
X
and
plus
1.
1, X plus 2, X plus 2.
yeah, it's got to be 2 and 1. Thank God the middle's 3, because that's the only thing that 2 and 1 can make. What do they both have in common already?
X plus
So they both already have an X plus 2. What's this first guy need that the second dude's got?
X plus 1.
Good, so you give him an X plus 1. What's the second dude missing?
X plus 3.
So you give it to him. Alright. This is where I always joke about if you have kids and you got 2 kids and give them ice cream and the one's got, he's got sprinkles, and then the other one's like, he's got a cherry, got something. Then you give the one give each what they're missing and they're still not happy, so just eat all of it. But here, this is not ice cream, so the math just takes it. What do we got on the top here? And now remember, I don't know, I think most of you guys are going to like doing this. When you have a negative in the middle, I highly recommend you automatically make plus negative. Because then it's really going to be your face that it's a negative going through.
So that 6 stays.
So what do you get here? 5x plus 5 minus 2x minus 6 all over this. Because that's what they both are. Now another big mistake is somebody just puts that and that together. It doesn't make any sense. Right? 1/4 plus 2/4 is 3/4, not 3/16, not 3/8. You're just collecting like terms, really. And then what do you get on the top here? 3x. What? 3x minus 1 over blah, blah. Good Lord, Jeff.
3x minus 1.
Please let that be nice. If you can factor, that is relatively simple. You factor, you see what they're missing, you give them what they're missing, get your like terms together. So here, this is kind of funny. This one looks like it should automatically always be so much easier. I'm just going to let you guys try this one. Just to save some of you from yourselves, are you allowed to add something to the top and bottom of a fraction? Like is 2/3 equal 3/4? Because I added one to the top and bottom. Is that true? Well, hell no. So why are you allowed to multiply top and bottom? Because fractions are basically division. So multiplying top and bottom, they would cancel back out. That's why that's allowed. So you can't just add 1 to the 4 piece. That is never allowed for a fraction. So what's really funny, give me a value for m. Just give me a number for m. 4. So if I had, so that would be 4, and that would be 5. So if I had like 1/4 plus 1/5, what's the LCD? Why is that easy? What's the LCD? 20. They don't share anything. So the 4 needs the 5, and the 5 needs, they need each other. Oh, they need you.
But in that one, it would make it.
No, come on now.
Oh, sorry.
So what is he missing that he's got? And let me ask this again. Does this guy have an M? Does this guy here, does it have an M in it on the bottom? No, it doesn't. Doesn't. Technical term. It doesn't. Can't waste time on the S sound in that school. You guys see that? I've said that so many times before, and I point out how insane it sounds. But that does not have an M. This does. So what's the first guy missing? What's the second guy got on the bottom? M. What's the first guy got on the bottom? M plus 1. So they're both missing each other. Oh. The same way you do this. 5, 4, you give them both each other. So you give this first one an M. You write this over again. Good Lord. Alright. So you multiply this one by M. Multiply this one by M plus 1. And be careful with the negative, right? They get plus and negative, so you don't forget to distribute that negative. Yes. We never multiply the bottom out, so you can see better if anything cancels. So what do you get? You end up with what?
Negative m minus 4 over m.
Bam! Solving is coming up very soon. This is simplifying, yeah. Here, do number 6 on the next page. Be very, very careful. This is not the same as the one we just did. You could.
Which one?
Pick one.
No, it's just one.
If you do both, then they like pass each other in the night. No. If you multiply by negative, they both change signs. So the one that's positive would become negative. You can do it. Now, do you guys agree that those bottoms are almost the same? Almost. Why are they not the same? There's a negative Oh, okay, so then just, I would recommend you do the second one, because it's sort of out of order. Do you see that, the 2 minus t? If I multiply the second one top and bottom by -1, then the bottom becomes the same as the first one. Oh. When you multiply by -1, what's 2 times -1? -2. What's negative t times -1? Positive t, and then you just write it with a positive one first, yeah. Is that cool? -1 times -t is positive t. -1 times 2 is -2. Now they're the same. And then you get, what do you get?
T squared minus.
And then you're not done.
So it does matter.
Not really.
Well, because I did it the other way, so I got -4 plus.
Yeah, so you get, no. If you do this first one, you should get 4 minus t squared,
Yeah.
which is still 2 minus t, 2 plus t. So how do you factor the top? Either way you do it, you get t plus 2 left. I like it. Real quick word about something that just came up. Somebody got that there? Alright, how do you factor this? I know.
X plus 5, X plus 2.
How do you factor this?
5 minus.
Good.
5
It's
plus
the 25 that's positive. It's the x squared that's negative, so there should be 1 negative x and 1 positive x. Difference of squares doesn't care where the variable is. All it cares is everything can be cut in half. Do
Oh.
you guys see that? Difference of squares does not care where the variable piece is. It just cares that everything can be cut in half. If that's in the front, its parts go in the front. Is that cool? If you said the answer here was x minus 5, x plus 5, you'd be wrong. You'd be off by a negative. So it really didn't matter which one you did here. Just I wanted to keep it more like what you're used to seeing. Maybe. Try number 8.
You don't factor under the ones that the second one is A plus 2. I don't know what you want to source that. Why did you think of that? You're such a child. She goes, oh my God, the car. 6, 7, 8, 9, 10, 4. Simplify that. Wait, simplify if you've never simplified it. Oh, it's casting. It's 2 over A. 2 over A. How did you get that?
Skip that step. Don't do that. You know, like the violence is where you probably don't. I think you're good. So which piece can you factor?
The middle.
The middle one. Out comes an A. I know there's 3 fractions there. I don't care. Doesn't change the idea at all.
5A.
Was the first dude missing?
A.
An
Minus
A.
3A minus 6.
And then this guy's missing
A plus 2.
A plus 2. Look at plus and negative, so you distribute that. So let's see what we get on the top here. We get
5A.
5A
Plus 10.
plus 10 minus 3A
Minus 6.
minus 6. I like it. All over
A times A plus 2.
A times A plus 2. Let me stop there. Just because it's 3 fractions is not a valid enough excuse for you to skip it or to go run it. You just do the same thing to all 3, right? Which one's missing what? And then what do you get when you combine stuff here?
2A plus 4.
And then you can factor the top. So you do. You guys see that? So that when you think you're done, just see if you can factor anything. Factor it, and then see if anything is common. And obviously, yeah, the A plus 2's kill each other. 2 over A. Alright, so a little preview. What piece?
She got it.
You got it? You just don't like it? Oh, you're not required to like it. I mean, that would be nice. I would love it if that was true. Alright. Is that cool? Jim, do you have a question?
Just like on the denominators, like factoring, that's easy for me, but like the out ones, so you're just trying to make them equal to the middle.
Yeah, so he's got an A plus 2 right now. This guy's got an A plus 2 and an A.
Okay.
This guy's got an A. So it's really obviously this guy is missing that A that everybody else has.
I just messed up on the last limited sign.
Or the little minus.
Yeah, these are
So that's why I say make that always a plus and negative so you don't forget to distribute that. I like it because I pretty much gave up on that first way I showed you.
yeah.
I think most of you guys are like, no. Alright. So we've actually done problems like this before. You guys remember how we did? And again, there was a method to my madness back then. Because I was trying to get you ready for when there are going to be variables on the bottom. Does anyone remember how we did this?
Multiply everything by 3.
Yeah, but I actually ended up not doing it.
Oh, okay.
First thing I did, for a reason, and you can do it that way. You can solve this problem that way, but it doesn't really help you as much
Okay.
with when there's variable expressions. What is the LCD? 30. Now make everybody have a 30 then. How do you make this first guy have a 30? So really it's the same idea, isn't it? It's you're giving them all what they're missing. 15 is missing a factor of 2 that 6 has. What is 6 missing? 5. What's 3 missing? 10. So that becomes 2w minus 5 equals, oh sorry, over 30, Jeff. There you go, buddy. 30 equals 10w. It's just kind of like second nature for me to not even write the 30, because what's the next thing we do? Once we get everybody being divided by 30, we, when everybody's divided by 30, we do what to both sides? Multiply by 30. Because then that kills all the 30s. Does this sound familiar at all? Just going to finish this up real quick. Gross. Now, on the heels of that, is that cool? Subtract 2w, divide by 8. Let's do one. This is a good one. I like this one. Let's do this one here. And we'll call it a day a little early. So guys, what did I say? I love when there's random weird things happen. What did I say entering chapter 7? The first step will be almost 90% of the time factor. So of course I'm going to factor.
C plus 4 and C minus 4.
Yeah, some of you guys will realize after do a few of these problems, this is basically going to be that. Almost always. So now, who's missing what? What's this first guy missing? Z plus 4. Second guy is missing.
Z minus 4.
This guy's missing nothing. That's nice for him. And then I multiply both sides by that thing, just like we multiply both sides by 30. We made everything have a 30 on the bottom, and then we multiplied by it. So we made everything have a this on the bottom, and then I'm going to multiply by that.
Z plus 4, Z minus 4?
Yes.
Okay.
Because now what happens? It cancels everywhere. So what do I end up with?
Z equals, Z plus 4.
Z plus 4
Plus Z minus
plus Z minus 4 equals 8. That looks so nice. So I get 2Z. Now, somebody help me out. Look at the very original problem. What can Z not be? What values of Z am I not allowed to use in that equation? Yeah. What makes the bottom 0? 4 and negative 4. Stay with me. What is the supposed answer? 4. But what we just say happens if I try to plug 4 in? It becomes 0 on the bottom, so it becomes undefined, right? So the only possible answer doesn't work. Therefore, no solution. Now, some people, stay with me. Some people, yes ma'am.
If you had written Z cannot be 4, like Z equals / 4, would that still be right or would that be wrong?
No, that makes it seem as if Z could be everything else.
Oh, man.
The answer is nothing. Yeah. Now, some people get upset about this. They say, I did all this work and math gave me some stupid answer. No, what's the very first thing we did after we made everything the same? We multiplied by Z plus 4, Z minus 4. What are you not allowed to multiply both sides of an equation by? 0. Hopefully that makes sense. You can't multiply both sides of the equation by 0. Did we know at that point that we multiply by 0? No. So this is math saying, oh shit, dude. The one of the first things you did was multiply by 0. You didn't know it at the time, but I'm just trying to help you. So this is not math being an asshole. This is math the only way it can be nice. So when you solve, guys, when you solve rational equations, you have to check and make sure that any answers you get do not make the original undefined. If they do, you throw them out. Yes, ma'am?
Can you like write how it makes it undefined? Can you try and plug it back in so you can see how that happens?
What's it do to the bottom of that? Makes it 0. So that would make that undefined. If I would have gotten -4, then I would have had to throw that out too.
So because it makes one of them 0.
Yes, I want you to understand, the minute that any piece of something is undefined, the whole thing goes to shit.
Got it.
Yes, okay. I like it. Alright. I think that's plenty. That's plenty for today. That's section 7.6 that we just got into. Oh yeah. We're crazy.